Hello everyone, how are we doing tonight? Just trying to get my screens all set up here. I already got one question, how to change backlash values. Hold on one second. I'm good. I've been crazy busy, so we're missing videos again. I apologize for that, but I do the best I can. Where the heck is the... I lost my analytics. Huh. Okay, any event. So how's everybody tonight? Actually, Josh asked for the live stream, so you can thank Josh for this one. I was actually out of town for a while for my day job and been really busy there and busy working on the machine and busy with the family. My son's been wanting to do a whole bunch of stuff, so I've been spending a lot of time there. So I just haven't had time to edit videos. I've got tons of footage in the can, um, just haven't had the time to edit it and get it out there. So backlash on the Fidels. That's the BL command. So if you type in BL and hit enter, it will then display what the current backlash settings are. And then to change them, you type in BL, comma, and then 1 for X, 2 for Y, 3 for Z, comma, and then if it's XY, you can enter in 3 numbers. I believe it's center, negative, and positive. And then if it's Z, there's only 1 backlash value. So that's how you can set the backlash. And those are in 10,000ths of an inch on standard machines, inch machines. I don't know what it is in metric. That I'm not sure on. But that's how you do backlash. Let's see here. Can I do more videos on putting full-size VMCs in a home shop? Sure, Stuart. What specifically would you like to see? We can do all kinds of videos. I'm like completely jammed up with video ideas, and I've got some really cool stuff that I'm going to be doing videos on. So there's a lot of videos coming. I want to get to these electrical videos because there's been a lot of interest in the electrical videos. I just haven't had time to make them. We also lasered the machine Thursday night, so there's going to be a video coming on that. So we shot the machine with the laser interferometer, and got some values for there. See you later, Gary. Thanks for stopping in real quick. So the initial values were actually very well. So if you recall, I made a video on how to do a machine survey using a step gauge. And when I did the step gauge, it's an 18-inch Moore gauge, and my X has 20 inches of travel, so I actually had to reposition the step gauge to get the full 20 inches out of it. And I also only used a 5/10 indicator. But with all that said, the axis was within 1,000ths of an inch over 20 inches. So I was pretty impressed. Excuse me, I got a sore on my tongue. I was pretty impressed with how accurate it was. The other thing that we confirmed with the laser is during the leveling video, or no, I'm sorry, during the ball bar video, when we ball barred the machine, we noticed that there was a lot of ABI error. The table of the machine kind of does this as X travels. And we didn't know if the whole machine was leaning, causing the level to show ABI error, or if there really was ABI error. The good part is that the level was exactly correct, and the machine does have ABI error, and it's a fundamental of the design, and it's about 20 arc seconds plus and minus. So when the machine goes X that would be X positive, then you get minus 20 arc second rotation, and when it goes X negative, you get a plus 20 arc second rotation. So we were able to verify that with the laser. So what that means is when you're doing this, depending on how high up off the table you are, because it's an arc, your x-axis will grow the farther up off the table. So when we lasered it at about 4 inches off the table, which is where your vise normally sits. So I do a lot of work in the vise, so we did it there as a good compromise in height, and that's why it measured a little bit long, about a thousandth of an inch. So we redid the axis survey with the laser, and then the repeatability of the machine is about 1.5 10,000ths, and our accuracy was about 2.5 10,000ths. So it came out very nice. Yeah, Josh, it's unfortunately a 4-axis machine. But I mean, if you think about the numbers we're talking about, they're very, very small. I mean, 20 arc seconds is, tiny. So overall, I was very, very happy with the survey. The other thing that we found is there was always a question mark on how square the z-axis was with xy. And the reason for that, it's hard to get a good judge on squareness when you have a little bit older of a table, because moving the square around on the table can change it that slight bit. And when you're looking for 5, 10, 20 arc seconds, a thousandth of an inch change in the height of the table, due to wear, makes a big difference in the angular error. So again, using the laser, the Z head is square within about 5, I think it was 5 to 10 arc seconds. So I was really happy with the way it came out. So Gary had a ball bar done on his 4020. Nice, came out good. Yeah, and a lot of people get these surveys done because they have to make certified parts. So yes, definitely. Or if you're machining like really expensive castings, the customer will demand that you have a survey done right before you machine their part, because some of these castings, you can get over $1 million for a casting, and they want to make sure you're not going to mess it up. Was that expensive to have done? Well, very, very fortunately in my case, the last video I introduced you to Brian real briefly, and Brian is a very good friend of mine, and he owns his own company that does machine calibration. So he owns his own laser and he owns the ball bar. So he came in on his own time and helped us out, and also gave me the information so that we can make a nice video on it and help you guys out. However, for a basic 3-axis machine that is less than 1 meter in stroke on all axes, he charges a flat rate of $150 an axis. So it's not horribly expensive. If it's over 1 meter, then he goes on to time and materials billing, just because over 1 meter it starts to take a very long time to do these surveys. But under 1 meter and then only 3 axes, it's $150 an axis. So not too bad. So you're in what, like $500 that's US dollars, to have a laser survey done, if Brian was going to do it. So fun to do. Really neat stuff. I learned a lot because I never did or seen a laser survey. I've worked with laser interferometers in the past, so I was familiar somewhat with how the laser measurement process worked, but to see it actually done and kind of walk through the steps with him, and he helped, and he let me do some of it myself so I could learn it. It was really cool because you have to aim the laser correctly, and the laser has to shoot parallel with the axes of travel. And it's kind of funny, how when you're using a test indicator, if the needle is not parallel with the part, you get cosine error. Well, the same thing happens with the laser. So if the laser beam isn't parallel with the axis of travel, you'll get cosine error as well. So he showed me how he aims it and aligns the laser and everything. So it was a really cool process. It was a lot of fun. So yeah, 3D performance. Yeah, it's not horribly expensive. It's not bad at all. So, and So after the survey, like I said, the machine is about 2.5 tenths over the entire axis of travel, and then so with the laser, you can only measure one feature per laser. So if you have one laser, you can only measure one statistic. So there's different optics to measure different things. I'm going to make a whole video of it. Yeah, I have some video of it. I just have video of kind of showing the survey process and the meter and stuff. But I'm going to make a detailed video on how it's set up and you know, how it's set up, what the process is, how it works, how the laser interferometer measures things. So there's different optics to do different measurements. So they have a linear optics set of optics that will measure linear displacement. There's an angular set of optics that measures angular displacement. There's a straightness set of optics that will measure straightness. So the reason why laser interferometer surveys can get so expensive, and depending on what you're trying to do, is for every axis you have to run a series with the linear optics, then run a series with the angular optics, and then you have to run that series twice because you want roll and pitch, and then you run another series with the straightness optics, and you take all that data, and then you can combine it together, and then figure out exactly how the machine is moving in three-dimensional space. So it takes quite a bit. Oh, what's the update on my portable torch? It's still right there, so there really isn't an update on that one. I've just been hammered doing all kinds of stuff. It wants to get done, just not enough time in the day. The latest thing is I got a package. I got to probably machine a part for this, I think. I got to package this up. This is for my kid's Halloween costume. So, yeah. And I used to be big into saltwater aquariums, and I was getting ready to take it down, and my son said, "Dad, I really want to get the fish tank going." So that's been the last 3 weeks of hectic work as well, trying to get that thing back up and running. So just busy with a lot of family stuff. So, oh, good evening, Rob. How you doing today? Yeah, the portable torches. It's almost there. I haven't machined any more parts for it yet. I'm trying to get the compressor up and running. Viewer sent me the sintered bronze moisture separator. So, and Rob's actually going to help me machine a tube for that. So I got that modeled, and it's just sitting there ready to be run. I just haven't had time to run it yet. Let's see here. So yeah, so the other video that we're going to be making is after the laser survey. We also redid the ball bar. So we've got a drive balancing video coming up as well. And all of these videos, I'm doing all these videos now because I've got a whole series of videos that I want to get done, and they're going to come out as well. And I think you guys will really like this. The Fidel owners will really like this. So yeah, so that's coming up too. Yeah, just crazy busy, How about you guys? I'm sure everybody else is cranking along as well. Oh, nice. Old 50 taper HMC. Cool. Yeah, let's see here. This week I've been machining PVC plastic for fish tank parts with my son. So that was kind of fun. I got him actually running the machine, and he seemed to enjoy that. So we made a whole bunch of parts together. I didn't film any of that just because I was spending time with my son. So, But yeah, we built a bunch of parts for the fish tank. It's so nice having a machine shop in your garage, you know. You need something and bam, you just make it. Oh, Josh, changing spindle bearings. Now that's going out on a limb. Awesome. What kind of machine? Oh, there's another Josh. Sorry, we got two Joshes, Josh M and Josh W. So Josh W is restoring a 1996 Bridgeport Torque Cut 22 for the high school robotics team I mentored. Oh, cool, cool. Did you comment on some of the videos or email me? Somebody emailed me about the first robotic parts. I can't remember who. I'm horrible with names. So Gary's also working on a Bridgeport, 4-horsepower Bridgeport. Cool. Yeah, somebody emailed me about the first robotics parts that I've been showing, and I've got a lot more of those to show. You can take a look at some of that footage if you want, since I haven't released any of the videos. Oh, you did the Fidel spindle bearings? How was it? And where'd you get the bearings from? Because I got quotes for the bearings, and the bearings were like $1,000. I've been thinking about doing my bearings, and I've never taken one of the spindles apart before, and I can't find anybody that will admit that they took them apart. One of the things that I want to try to do is I've got a little bit of run out my machine, so the spindle taper is not in the rotational axes. The spindle tapers off a little bit, and normally there's an adjustment at the top of the spindle so that you can angle the spindle so that the axial rotation lines up with the taper. And I didn't know if Fidel has a nut on the top that you can adjust that with. So. Oh, hello, Bob. Good evening. Thank you. Thank you. Yeah. So yeah, the spindle probe is another one that I've got coming too. Honestly, I haven't touched the spindle probe yet. I've been so busy, I haven't been able to do anything. I've been writing a macro for tool setting, and I think that's going to be awesome. I think a lot of people are going to like that macro that I wrote. So what I found out when I got the tool setter probe up and running, the Fidel tool setting macro works just fine, and it works well, but it's a very serial process. So you put the tool in, and then you measure the tool. You put all your tools in, and then you have to type in the information and measure the tool one at a time. Type in the information, measure the tool. What I like to do is I like to put all my tools in, then I want to enter in all the data, or what I really want to do is have my Compact Rio send all the data based on the CAM file, because in the CAM you know what tools you're going to use, so as long as you put the right tools in, which you should anyway because you got to machine the part right, then I want it to go and measure every single tool, both length and diameter if needed, in one shot. So I'm writing a macro to do that, and I've got it about 75% done and tested. So that's also something I've been working on, but I haven't touched a spindle probe. It's still sitting on the bench, so I really want to get the spindle probe going. I also had a viewer send me a hammer, whatever, 3D indicator probe, and those things are really cool too. I was surprised at how accurate it really was. It's pretty accurate, and I've been using that quite a bit. So that was pretty cool. That was awesome as well. I forgot to put that in the thank you video. I can't believe how much stuff people are sending me. It's overwhelming. It's awesome. The generosity it just blows my mind. Oh, let's see here. Sorry, let's catch up on the comments. So Bob's got Bob might add spindle probes to his machine. I would definitely do it, Bob. If you're doing any type of either production running or prototype running, the probes, A, will increase your accuracy, and B, it's going to increase your speed. So if you can justify the cost, I would definitely do it, and I would definitely look at eBay. All the stuff I bought off of eBay, and the spindle probe came from, or the tool setter probe came from eBay as well, but it was donated to the channel. but you can get a pretty killer deal on eBay. Yeah, Josh W. Yeah, getting machines that haven't been cleaned in their life is a normal thing. Unfortunately, a lot of companies just don't do preventative maintenance, and I don't know why. It's penny wise and pound foolish not to do your PMs. So Darren's working with First Robotics. Yes, First Robotics is great. I love First Robotics. It's such a good program, and seeing the kids make some of this stuff is really cool. You know, they are very innovative. I didn't think Fidel CNC sold the actual spindle bearings. Maybe I should talk. Maybe I should call him and talk to him. No, they're not cheap. The spindle bearings are not cheap. Heimer? Heimer, thanks. Thanks, Josh. Yeah, even the Heimer versus the Renishaw probes. I mean, it's a night and day difference. It's so much faster and it's so much more accurate. So, what's a ballpark for the whole spindle probe system? So spindle probe system, you need the probe that actually goes in the spindle. I think I got mine off of eBay for 500-ish. And then you're going to need the optical reader. Now, mind you, mine's a really old version of spindle probe, so it's longer. So the older ones are longer, so they take up a lot more room. I was actually thinking about just kind of re-engineering the electronics on it and shorten it up, make my own housing. Any event, getting off track here. So the optical reader, you're probably looking at another, you know, I got mine for 500, you know, maybe 700, depending on how the eBay auctions are going. All this is off of eBay. And then at minimum, you're probably going to need a MI12 interface, machine interface, unless you try to do something like I did. But I would highly advise against doing that unless you're, you know, electrical and software engineer. So that the MI12s, I've seen them go anywhere for as low as 100 and as high as 300. So you're looking at least 1,100 to probably $1,500 for a spindle probe setup for all the pieces parts that you need. So I think that would be a good ballpark. Yeah, my Fidel was awful when I got it. It was covered in God knows what. I don't even want to know what it was covered with. Yeah, the paint coming off the machines is also a common problem, Josh. Especially if you're using coolant or cutting oils, a lot of them are not compatible with the paints, and it just strips the paint right off. Really, 350 bucks for a pair of spindle bearings from Fidel right now? You got the link? Vlad is still confused about the way Fidel measures tool offsets in G43 on Fusion. Well, what are you confused about, Vlad? Maybe we can help you out tonight. Hey, Clinton, how you doing tonight? Huh? I must have Marty's saying they show spindle bearings on their page as well. Huh? Oh yeah, Google has been, you know, a nanny about posting the links. They think you're spamming or advertising. Yeah, I'll look it up. I'll look it up. So I didn't know they posted spindle bearings. Here, let me look it up right now. Why not? I didn't know you were that close to me, Josh. Is it under the bearings section? Is there a bearings section? Bearings. Oh, I'd look under spindles and pulleys. Well, maybe that's why I didn't find them then. Yeah, I think that motor that I had rebuilt. Oh, okay, you're not that far from me then. You're like maybe 3 hours if you're in Northeast Ohio. That's not bad. It's what 2 hours and 45 minutes from my house to Cleveland, downtown Cleveland. Oh, look at that. Okay. Wow, those are cheap. How do you know which set you need though? Is L for lower and U for upper? Is that a good enough assumption? Oh, so it's 700. Okay, so that's close. I think the quote I got was like 950. So yeah, I've talked to Fidel CNC quite a bit. I really appreciate their web page. And the guys are great there. So Josh, is there an adjustment on the top of the spindle so that you can kind of actually skew the spindle cartridge a little bit to align the bore of the taper per se? it's it's crossed my mind. Brian's also offered to help me, but we've never pulled one apart, so we don't know what to expect. Um, One of my thoughts was to order a spindle cartridge that was all done, and then just pay the core charge so I can keep my old one, so then I can take the old one apart. So the 4020 has an adjustment. Well, is the adjustment inside the spindle, inside the spindle cartridge, Gary? It's not tram. It's an adjustment on the rotational axis of the core of the spindle that you need to adjust to get the runout out. The runout out. Yeah, you got that. So let's see here. Vlad didn't jump in at all. There's no adjustment that I remember. Okay, maybe see that's the other thing of why I've been trepidatious of just ordering the bearings, because if the spindle taper needs to be chromed and then ground again, I'm almost better off just buying the spindle cartridge. You think just changing the bearings will take out the runout issue? Because I got quite a bit of runout. It's like at at about 8 inches down the spindle, it's a thousandth of an inch. It's quite a bit of runout. Yeah, you'll like my bubblegum and baling wire. So I'm using the stock spindle cooling fan, the motor cooling fan. Um, but back in ye old day, Fidel did not put a filter on that fan. So while you're running, the fan basically just sucked in all the coolant mist and blew it right through the motor. So my motor was just packed with crud. Um, so then they started selling this retrofit kit where it's basically just a car air filter that would fit on the spindle, and then you could filter the air so you wouldn't blow coolant through the spindle motor. But I did the math, being an engineering nerd, and one of those filters cuts the airflow through the spindle motor drastically. So I calculated out that to get that much airflow through the spindle motor, you'd need three of them. So they're like $5 a piece. So I bought three and then I stacked it up. It looks stupid, but it works good. Yeah, I know Fidel CNC will do spindle cartridges for me. So Vlad, yeah, so Vlad, you're getting caught up in the whole positive negative issue. Um, so let me see if I can explain this right. Hold on a second. Hold on a second. Let me make sure I get my math right here first, just so that I got my head screwed on straight. Okay, so what happens is when you use G43, hold on, let's pull up the manual. How about that? Because then we can read it from the manual verbatim together. Let's help Vlad out here, guys. G codes. Okay. Let me switch my view. Let me move you guys over here. Okay, so here's the manual for Fidel. So down here, this table is the key table here. So when we set a tool offset, if you follow the videos that I did, basically what you're trying to do is you're trying to move the zero of the machine from where it's at its tool change height down to, you know, where your reference is. So if you're going to use the table as your zero datum for your tools, you need to move the zero from tool change height negative down to the table. So if you look here, if the G43 code, if you're using G43, which Fusion uses G43 by default, I don't know very many people that use G44. Almost everybody uses G43. If the offset in the tool table is negative, it moves the tool in the minus direction, meaning it moves the tool down. So the zero will be lower. Okay, so that's why the numbers are negative in your offsets. So, you know, having a negative value is fine, because what it's doing is you're moving your tool down, and say your tool sitting at the table is, you know, minus 10 inches. So you put minus 10 in the offset. So then when you're at minus 10 inches at the table, the actual Z value will read 0. Okay? Does that help at all? So by getting negative values when you're doing your tool offsets, that's correct. Okay? And then that will move your Z offset based on your tool setter, you know, to wherever you want it. So I use the table as my 0. Some people like to use a gauge height block or some other reference, but you know, the table never changes, so that's why I use the table. And then when you do your fixture offsets, say your part is 4 inches off the table, in your fixture offsets, that's the DF command. That's your G, G54, G55, G56s. Your fixture offsets, you'll put a positive Z offset to lift the 0 off the table to the, you know, top of your part or your bottom of your part, whatever your Z0 is. So does that help? Maybe? Let's see here. Let me catch up. Yeah, Josh, my taper looks fine. It doesn't look like it's messed up. I think it's just worn a little tiny bit from the tool changer being a little bit misaligned when I got it. So, good evening, random audio guy. How are you tonight? Yeah, Darren. Yeah, as long as you're pushing enough air through the spindle through the spindle motor to keep it cool, you should be good. I don't know the exact specs of the fan I got that's in there. It's the stock one that was in there. I took it out and I hosed it down with parts cleaner and I washed all the stickers and everything off of it. So I have no idea how many CFM. If you put your hand at the bottom of the motor, though, you can feel a lot of air coming out of it. So yeah, it's not bad. I'm actually the spindle motor still isn't right after I replaced it earlier this year. So I'm actually gonna order. I think I'm gonna end up ordering a set of pulleys, a brand new set of pulleys. I've got a line on a brand new spindle motor, so I think I'm gonna do that and put brand new pulleys and brand new spindle motor in. And then when I do that, I'm gonna measure the run out on my spindle, just make sure that my spindle isn't bent. You know, I hope it's not. So, yes, I have replaced the Belleville washers for the drawbar force. Yeah, when I got my machine, my drawbar force was down like 300 pounds. It was ridiculous at how little it was. I was surprised the tool didn't pop out of the spindle. So yeah, I mean, for all I know, for all I know, the spindle actual core of the spindle could be bent. Who knows? You know, the machine looked like it lived a hellish life. Yeah, when I did my drawbar, I should make a video of doing the drawbar. I probably should take it apart and re-lube it. I haven't checked my drawbar force lately. But yeah, that's sketchy as all heck when you're when you're compressing those Belleville washers and you know there's a couple of 1,000 pounds of force on that thing and your head's right next to it. And then putting in those little two half, you know, I don't really, they're kind of like C-clips, but they're not. But man, sketchy. You replace your Bellevilles yearly? Really? They wear out that quick? I would be surprised they wear out that quick. Or are you guys using the Never Seas on them to keep them lubed? Because a lot of the times the Bellevilles don't get weak. Just the lube gets dry and they get sticky. Oh, okay, Vlad. Yeah, yeah. So if you're using the sorry for jumping around here, guys. If you're using your table as your zero for your tool offsets, so then every tool when you type in Z0 will come down and just touch the table. Then your Z work offset needs to lift the tool off the table, so it wants to be a positive value, and that value is based on how high off the table your Z0 wants to be for your part. So when I'm machining in my vise a lot of the times I'll use the bed of the vise for my Z0, and then I'll just put the material in on the bed of the vise. So I have a work offset that's positive. I forgot what it is, like 2 3/4 inches or something like that, that will lift the Z off of the table and up to the bottom of the vise. So yeah, so negative tool offsets to bring the tools down to the table, and then positive Z work offsets to bring your Z back up to whatever part height you want. And again, the reason for doing that is just because the table never changes. Some people like to set their tools based on their vise or their part, but what happens when you take your vise out of the machine? Now if you're running 20 some tools, now you got to reset all those tools because they were referenced to the vise that's no longer there. Well, the bed of the table is always going to be there, so that's why I use the table. So somebody suggested to me, and I haven't tried this personally yet, but they said high pressure grease mixed in with a little bit of STP. and they said that is slicker than snot, and the air from the tool change drawbar won't blow it off, and it won't dry it out, and it will last a million times longer than Never-Seez. They said, you know, don't bother using the copper Never-Seez. You're welcome, Vlad. Thanks for stopping by and chatting with us. I'm glad we could help. Wow, Josh, you actually broke Belleville's? Hey, Stefan, how's things on the other side of the world there? You guys are just starting to get into summer. We're just starting to get into winter. But don't tell the weather that, because summer showed up 3 months late here. It's already mid-October and our leaves haven't even started changing colors for the most part. It's kind of weird. Wow, yeah, I haven't broken any Bellevilles, that's for sure. And none of them were broken when I took when I pulled them out. Flat out like a lizard drinking. I think we'll leave it at that, Stefan. Huh, wow. Yeah, you're probably cutting a lot heavier stuff than I am. I mainly just cut aluminum. So, but did you guys see Tom Lipton's and Robin Renzetti's 123 block setup? A friend of mine and I are thinking about making a run of those. So might be getting in some A2 tool steel and trying to machine a couple of those. So we're gonna machine them on my machine, and then he's gonna surface grind them on a surface grinder to bring them in true. And then there's a guy up in Lockport I talked to that does heat treating, so he'll heat treat them for us, and then we'll grind them. So we might be making a run of those 123 blocks. They look really nice. So, and I don't have any 123 blocks, so we'll make it'll be a good project. It'll be fun. How's the probe and tool setter? The tool setter is working great. I said earlier in the stream that I'm writing a very specific Fidel macro to streamline the tool setting process a little bit better. The probe is still sitting on the bench. I haven't even dialed it in yet. But I've got this really nice tense indicator that we'll be using to dial it in. So hopefully we'll be doing that very shortly. Oh yeah, the retaining bearing for the thrust bearings. Yeah, that's a tough one. Try a little tiny bit of heat, Clinton. Just a little tiny bit. You know, don't roast it, but a little bit of heat just on the nut itself to try to expand the nut, and then hit it with the impact. I don't know if they will be for sale or not. Every time I come up with an idea of making something for sale, it always seems like John over at NYC CNC puts it up on his website. I was actually thinking about making those MIDI pallets, and then a week after I thought about making them, you know, he announced that he was going to make the mini pallets, and then he bought a Haas to make them with. So yeah, but I don't know. We'll see how the first runs go, and we'll see how accurate we can get them. I think we should be able to get them within a tenth, so that's more than enough for most people. Sent me a message with a link to some pics of the repaint if you're interested. Ugh. Hey Josh, is it okay if we share them, or you want to keep these private? Yeah, that was dirty. Oh, good evening, Easton. How are you doing today? I want a set of Atman blocks. Oh, Clinton, you already tried some heat. Hmm. Hmm. That bad, huh? Jet in my future. I want to download your LabVIEW knowledge. Um, I don't know if they've perfected the neural PC interface yet, but you know, you're welcome to ask questions. You know, I'll share you some LabVIEW help if you want that as well. Let's see. Oh, I'm good, Easton. Just slamming busy. So you know that's why I've been a little bit of short on the videos again. Just day job is crushing me. I've been traveling for work lately. So yeah. Hey Bob, good to see you. Thanks for stopping by. So let's see here. Let's download a couple of these. So these are these are pictures that that Josh sent. Let's see here. Let me make sure there's. I want to look through these just to make sure that there's nothing in here that we shouldn't share. I'd like to be courteous to all. Yeah, I'm glad to be home too. My son was starting to miss me. Let's see here. Okay, so these pictures are from Josh Wentworth. So he just sent me these, and these are of the. You said it was a Bridgeport that you were working on. So this is what he had to deal with. Yeah, that's typical. You see all that chips in the tool changer there? Oof, ouch. So, see here. Did I take the blue pill or the red pill? Hmm. I don't know. I think I'm kind of partial to the red pill. Yeah, a lot of people like that Threadmill video. I get a lot of good feedback on that one. That video was probably the hardest to nail down. So yeah, so here's a whole bunch of crud. Let's see here. What else we got here? Pressure washing with a Tyvek suit. There you go. That's a good way to get rid of it. I wish I could do that. I didn't have a pressure washer at my disposal at the time I did my machine, so mine was all elbow grease. Nice little paint booth setup. There's your first flag. Cool. You look good in Tyvek there, buddy. Nice. Oh yeah. Yeah, that looks good. That's what we're used to seeing right there. That looks yummy. That's pretty much how my machine looked. Uh, do I know how to measure the sync error in Z when rigid tapping? Like if you were going to try to design your own controller to do rigid tapping? Yeah, the tool change is looking better. Nice red. Wow. Josh, man, you should be a machine restorer. That's looking mighty fine. It's amazing how similar that looks to a Fidel machine. Even redid the graphics. Those are the nice touches. Four weekends. You did that in 4 weekends? That's impressive. That's a lot of work for 4 weekends. Hey, close the door. Hey, close the door. Hold on, guys. No. It's okay. Hold on. Ooh. Hold on, guys. Let me be right back. All right, sorry about that. Yeah, that's really nice work, man. Yeah, I didn't go that whole hog. I just spit on it and wiped it off with a rag. Yeah, maybe 5. Still, that's a lot of work for for 5 weekends. That's pretty good, man. Nice job. Yeah, looks good. Thanks for sharing. That's awesome. Yeah, it came out really nice. Oop, where are we going? Stop. Okay. It was back together in another 2. So going back to your question on rigid tapping, uh, basically, in a nutshell, the way that rigid tapping works is your primary control axis is the axis of least response. In most cases, that's the spindle motor. Okay, so then what you do is you link the rotation of the spindle to the Z feed. So then you have an encoder on the spindle that is measuring your rotation, and then you take that rotation and you know that for a given position you need to be at a certain depth with Z. Okay, so then as your rotation is increasing, then your Z command is also going to increase and then decrease. So that's pretty much how you do rigid tapping from a controller aspect. But you want the following axes to be the axes of the best response, and you want the master to be least response. So, hold on, guys. What's up, dude? What's wrong? Sorry about that. Little one, little one woke up. Yeah, you can post a website, Darren. Google's been kind of tough on posted links, but if you want to email it to me or forward it to me, I can post it as well. Yeah, no problem. Um, yeah, the reason why I like the Fidels is just the parts and availability, and the manuals are all out there, so they're easy to fix and they're cheap. They're cheap to fix compared to everybody else's machines. So Steve, on the Fidel specifically for rigid tapping, there is another encoder that is separate from the encoder that does the spindle orientation. So the spindle orientation and lock during a tool change is all done on a magnetic prox sensor. So if you look at the top of the spindle pulley, right at the spindle, you'll see a mag prox sensor, and there's a magnet in the spindle pulley, and then you've got the detent in the spindle pulley that the air solenoid locks into. So that's how it orients the spindle for a tool change. Fidel kind of did this a little bad. It's one of the design flaws, in my opinion, that was really bad. They put the encoder for rigid tapping on the top of the spindle motor after the belt. And the reason why that's not ideal, it's not bad, but it's not ideal, is that if the belt slips a little bit during tapping, it will get out of sync. So, but the encoder for rigid tapping is sitting on top of the spindle, and then that encoder is fed into your VFD or your vector drive, and then it's mimicked out to the spindle controller board for then the rigid tapping option. So that's the parts in play that do all of that. Yeah, sorry guys, my son woke up, so he needed a hug goodnight. So yeah, like Tapmatic, the floating holders. So be careful. There's a whole bunch of different type of tap holders out there. Rigid tapping is literally just that. It's rigid. You put the tap in a collet or a collet holder that has a square drive in the end of it. I haven't tried those yet. I got to get a couple of those. Those would be fun to try because it prevents the taps from slipping in the collet. Um, some people say that the negative of that is that on the turnaround, nothing is ever perfect. So the synchronization between the rotation of the Z or the rotation of the spindle and the feet of the Z is not perfect. So on the turnarounds, you tend to put a lot of stress in the tap, either in tensile or compression. So then to combat that problem, and again, I've only broken one tap in the machine. Granted, I'm not making a million parts a day. There's some tap holders out there that only give like 4 or 5 thousandths of an inch, and they have a really, really, really high spring rate. And they're only designed to relieve that little bit of tension or compression that you see on the turnaround. The benefit of that is you get, pretty much the same accuracy that you do in rigid tapping, but then you supposedly get better tap life because it can give a little bit. Survey is out whether or not you actually get extended tap life or you break less taps. I'm not really sure on that. I'm not sold on it. I use ER collets when I do my tapping, and I've done aluminum and steel and haven't had any problems myself. And then you have the true floating tap head holders, which are for machines that aren't tightly synchronized so that the tap head can float. The downside to those is you don't get the accuracy. So with rigid tapping, you can pretty much tap all the way down to the bottom of the hole within a couple of thousandths of an inch, depending on how accurate your machine can control the spindle. With a float tap holder, it's very hard to tap a blind hole, and then also the tapped hole, the threads will start getting shallower and shallower as the tap wears, because you need more preload to get that tap to initially bite. So those are the pros and cons to the 3 different types of tap holders. But yeah, there's a whole bunch of tap holders out there. Can I talk about the changes we had Fusion 360 make for rigid tapping? The original Fusion 360 post for Fidel did not support rigid tapping at all. So I helped the gentleman from Fusion, or from Autodesk, that was doing the post processor. I actually offered to do some of the work, but they did all the work themselves. I just provided some feedback on how I did it, and I provided them some example code. And it was actually kind of good that they kept the work there, because my schedule just got completely hammered, and I kind of left the guy hanging for a little bit. I apologize to him for that. I just got a whole bunch of work coming in, both day job and machining work, and I couldn't take the machine time to test it out. But the original Fusion post did not work rigid tapping at all. So Autodesk was able to incorporate both rigid tapping and non-rigid tapping. So now on the new Fidel post, you'll see another option in the drop down when you do that initial post menu, where it will ask you if you want to do rigid tapping or not. Then the other bug that I found in testing the latest post was with Fidel. There's a weird bug in the canned cycle moves. Another person that I talked to a lot found this bug as well and said, "Hey, do you know anything about this?" And I was like, "Yeah, I know of it. I don't know what causes it." So I spent a lot of time figuring it out. And basically, if you have a feed move on a Fidel machine before you do a canned cycle, like a drill cycle, then in between each hole, the machine will want to feed between each hole rather than rapid between each hole, which can be very, very frustrating, especially if you're drilling like a tiny hole and you're feeding at like an inch a minute or something like that. It's just, and your holes are spaced far apart. So the fix for that is basically to just put a G0 before each canned move, so that canned cycle will rapid in between the holes rather than do a feed move. So yeah, all of those items are fixed. And the last post that they sent me, I ran through the whole entire thing, top to bottom, every single cycle, and it looked real good. So that's the Fidel post processor in Fusion. Yeah, no problem, Steve. Yeah, make sure that orientation sensor is adjusted right. And the other one that you should make sure is adjusted absolutely right is the drawbar release switch. So what you want to do is you want to swap the air lines between the orient cylinder and the drawbar cylinder. So then rather than locking the spindle, it will actually just keep the drawbar pressed. And then there's a diagnostic screen that you can go into. This one's actually in the manuals, where you can adjust the prox sensor that says whether or not the drawbar is completely released. You just want that to trigger when the drawbar is fully released. That's how I ripped apart my drawbar, and it was nasty. Ooh, Gary, your encoder was loose? Ooh. I had a problem on my machine when I was running it at first. It would be machining, and then all of a sudden you hear this boom, and I was like, what the heck was that? And it took me a while to troubleshoot and figure it out, but up at the encoder that's sitting on top of my spindle drive motor, the connector on the encoder, somebody butchered it. Here, I actually probably got a photo of it. And it was completely screwing up the speed feedback for the variable frequency drive. So every once in a while, the variable frequency drive would think that the spindle stopped, so it would just give it a huge slug of current. It was literally sounding like somebody was hitting the machine with a hammer. So let's see here. Yeah, I haven't tried the tap collets. I mean to get some. Oh, there you go, Darren. There's your link. Hold on a second. I'll pull that up. We can take a quick peek. Yeah, I've never had a tap slip in a collet either, Stefan. But yeah, the only difference between a standard collet and a tap collet is at the very top of the tapping collet, it's got the square drive that the tap will go in. Yeah, Gary, I was going to try the Technics tap collets. I saw those. Have a good night, Drew. Thanks for stopping by. If I haven't missed you yet. Yeah, Josh, it's probably whey oil that seeps through the casting. Okay, I think I'm all caught up here. Let me show you how bad a wiring job it is. See if I can find it real quick here. Well, you know what? I might have a picture of the spindle fan. Somebody was asking about what size spindle fan there was earlier. I'm looking. I got a lot of pictures of the machine. Oh. Did I show you guys this one before? This is what happens if that... this is what happens to your drawbar if that drawbar switch isn't adjusted correctly and the Z head picks up before the tool is completely released. So, yeah, you can see. So this ball got ripped out of the socket, and then it hit the floater with so much force it cracked it. That was about a $500 oops. Let me see what else. See if I can find that. Oh, there it is. Come on, zoom more. How do you zoom more? Ah, there it is. That's the one you want to see. Check this out. So that is the wiring for the connector on my spindle encoder. Yeah. I don't know who did that, but nice job. So needless to say, if you're running your machine and it sounds like every once in a while somebody's hitting a spindle with a hammer, it's probably the encoder not giving a good speed sense. So needless to say, we cut that right off and we just installed a brand new connector. That's not space shuttle ready. Yeah, you won't find any of these type of connectors on the space shuttle there. So it just looks like the person didn't understand how these connectors work, because it looks like they tried to strip the wire on each one of these a little bit. It basically all you do is you just take the wire and you push it in, and then these fingers cut the insulation. You don't have to strip it. So, and what was doing it is, if you look at this red wire here, there's this little whisper right here, and it shorts out to blue. That's what was causing it right here. So it just, every once in a while, the vibration would make an intermittent contact. So there you go, guys. Oh, here's the... Somebody was asking what spindle motor fan is used. This is the spindle motor. So this fan is the fan that is in the top of the spindle motor. At least in my spindle motor, I don't know if they use a different one. So but there's your model number right here if you want to try to look them up. I think I looked this fan up. It was like $100 fan. It's not a cheap fan, that's for sure. Yes, I was their 3D Performance. I was that's why I added those air filters on the top of my spindle to keep the junk out of it. So here is one of my. This is the X-way cover for the machine that wraps around the edge of the table, and this is how I knew I had a major problem. I pulled this cover off, and all these little balls were sitting in the shavings, and I was like, "Oh, look at that! Where'd all those balls come from?" Well, I'm sure you can guess where all those little balls came from. Yeah. So let me see if I got a picture of the rest of it. Oh yeah, yeah. Here you go. So this is what this is actually an up close picture of the linear rail. This is where the high precision bearings are supposed to roll, right here. That's the bearing race for the linear rail. That's the problem my machine had. So, and then this is what the truck looked like. So there you go. There's no problem there. What's the problem? There's nothing wrong with that. Here's what it looked like after I cleaned all the schmaz out of it. And for the life of me, I don't know how this happened. I mean, I've never seen an end cap of a linear bearing blow off like that. So, and there's no hard stops on these machines, so it's not like it ran into a hard stop and smashed the cap or something. So it was weird. I couldn't figure out what they did. If you hear a noise, turn up the music. There you go. Just keep running. Yeah. So needless to say, the end cap broke, and all the balls chose to exit. Well, here's a pic where you can see the balls up close. You can see how bad even the balls are pitted. I mean, look. I mean, it's just amazing. It's almost like water got in or something. I mean, it's completely roached. So, but that's the reason why we had to put a brand new set of X rails in. Josh says, I'm convinced that way covers exist in some alternate dimension and chips just pass right through them. That's a good hypothesis. That machine was run by Forrest Gump. Yeah, good one. Here's what the underneath of the Z cover looked like. So this is the Z way cover right here. So, and this was just completely full. And then underneath that is what my tool changer looked like. So this is the platter for the tool changer that holds the tools. Those are the tool pockets. Yeah, I had quite the mess on my hands. Let's see if there's anything else interesting in this folder while I'm looking. Yeah, here's what underneath my saddle will look like. Wow, well that's got me beat, Gary. He says his 4020 was so full of crap the axes wouldn't even move. Yeah, mine moved just fine. It's just, what's that noise? I wonder what that's doing. So, and here's actually a really good picture. You can see why this machine has that Abbey error that I keep on talking about. So the way that Fidel did their way covers. So here's the Y linear rails right here, and here's the Y trucks. Okay, the Y way cover goes through this notch right here. So you see that notch? So there's this huge notch cut in the middle of the saddle. And then there's another notch here so that the way cover wraps around, and then this side cover comes up. So, you know, it's kind of hard for the chips to migrate their way in there. But it's this design, and you can also see how far out the X trucks go. So the X trucks go all the way out to here, and you can see there's this huge cantilever when the table's all the way over. So it's literally the saddle that starts to bend in this section right here. And that's why this machine has so much Abbey error to it. So, but the nice thing is it's only at the very ends. You have to get out past about, what was it? It was 12-inch circle was good. So 6 inches out of 10. So just the last 4 inches is where the Abbey error really kicks in and starts getting bad. So the center of the table is good. It's just when you start getting out to the extremes. So, but that's why this machine is the way it is. Can it be shimmed? Well, it really can't be shimmed because, you know, the saddle rides. You know, the way cover goes through the center of the saddle, so you really can't, you know, shim it or strengthen it because you would then, you know, block off the way cover. So you'd have to completely redesign the way cover system in order to try to beef it up a little bit. So. Yes, you are correct. The casting is flexing. Basically, the casting is flexing right in this area where they, you know, cut this slit out and then cut this relief in. You know, that's exactly correct. Ramzo cloud? So, yes. But yeah, I had to. I didn't have a choice to replace the X-rails, and then when you're this far into it, basically I replaced the X-rails, brand new X-rails, straightened them. Then I pulled all the caps and cap screws out of the Y rails, straightened the Y rails, and then we came back and we shimmed the trucks here. So you on Fidels you shim here or back here in the same spot to square X and Y. So, you know, while you got it apart, you might as well fix it. Move the machine to orbit and your problem is solved. You are exactly correct. Gravity is a you know what. Yeah, 3D. Basically, what ends up happening is as the weight of the table gets close to the edge of the saddle, basically the saddle is actually dropping a little bit. It droops from the weight, you know. So what that causes is the table moves back and forth in a slight arc rather than staying, you know, true. You know, if they space the Y rails out a little bit more, you know, that would also, you know, alleviate some of that issue. It's just the design of the machine. Any idea what the minimum height is of your machine? Just curious if it can fit underneath my garage door. The door header is 84 inches. The minimum height of my machine is exactly 1/2 inch less than my garage door, but I'd have to go out and measure it. I think it's like 82 inches or something like that. No, the top is not curved. The table itself is perfectly flat. I have a very good table. But what happens is the whole entire table, as you start going out towards the end, because the saddle gives a little bit, that side of the table drops. And what that does is that effectively makes the table arc rather than stay straight. But the table does not move or bend. It's just the saddle. Bob, you can get the machine under 7 foot. I have a 7 foot garage door plus like 1 inch, and it will fit. But you have to take off the Z. You have to take the Z axis motor off, and you have to take down the Gator Track wireways for the Z head, the Z column, and then you got to lay those on its side, and then you got to lower the Z almost all the way down. But you can get it just at 7 feet. Yeah, it's flexing. The rails aren't curved. It's just flexing. Yes, the rails do flex as well with everything else. Yeah, if you just be careful when you remove the Z-axis servo drive motor. Um, the Fidels come with a couple of different couplings. If you have the coupler that's got the 2 fingers, make sure you mark which way that coupler goes together, because you can put it together 180 degrees apart. And if you put it together 180 degrees off, your tool change height will be wrong. So make sure to mark your coupler before you pull your Z motor off. Yeah, the table's only connected in 4 spots. There's 4 trucks, one in each corner. Dusty Fields, I need help. Help me, please. Okay, what do you need, Dusty? Thanks, Darren. Have a good night. Yeah, I think Dusty will be the last one, and I'm gonna go off to bed as well. It's 11:30 now. So, Josh requested a live stream, so I try to aim to please. What's up, Dusty? What do you need? There you go. Nice. Bob called it. Okay, guys, well, I think I'm going to wrap it up if nobody else has any other questions. It's earlier in California, just 3 times the cost of living. Yeah, I just actually came from California. I spent a week out there, up near Sacramento. About what, like maybe 3 hours where all the forest fires or all the fires broke out. So dry as a cinder there, man. Holy cow, it was dry. You're welcome, Bob. Have a good night. No problem, Steve. Thanks for joining us. Thanks for coming. Yeah, they're having a really bad set of fires. I left, I think, about 2 days before the first fire broke out. Hey, how was the stream quality tonight, guys? Did it drop out at all, or was it real good? So on the ER set screw holders. That depends on what you prefer, Josh. Set screw holders are more rigid than ER holders, but ER holders are more flexible. So take your pick. Yeah, I'll let you know, Josh. I haven't decided what I'm going to do yet. I want to get the spindle motor straightened out first, because the spindle motor is still not right. My belt squeals like a banshee, so something still isn't right. Awesome, cool. I upgraded my internet a couple of streams ago, and since then I upgraded my service router. So cool. Set screw holders are okay. Just don't use set screw holders on really tiny end mills. Maddie D, is your machine wired for 4th axis? Yes, my machine is wired for 4th axis. I don't know if it works, but it is wired. And I have the iron. I have the iron for a 4th axis, so I got to find a motor, and then I got to machine a coupler for it, and then I've got to get a motor that's a DC motor, and then a resolver that will work with my machine. But yes, I hope to do 4th axis sometime. So yeah, shrink holders. Well, you know, Peter over at Edge Precision, he uses shrink holders, and he just uses a torch to heat them up and cool them down. I was told you're not supposed to do that. But you know, if you don't need the fancy machine to put the tools in and out, the shrink holders aren't, the actual holders really aren't that expensive. Ah, yes. Well, on my next machine that I buy that's 15,000 RPMs at 30 horsepower, I'll think about shrink holders. But yeah, shrink holders are the ultimate solution. You know, they're really, really, really good rigidity and, you know, all of the above. So. Peter said he's been torching his shrink fits forever, and he says he's never had a problem. So, yeah, proof's in the pudding. I don't know. So, oh, I use a torch all the time. Oops. See, there you go. There's another person that uses the torch. Yes, Fidels are capable of simultaneous 4th axis, and actually, from what I understand, is they can do simultaneous 5-axis machining too. But I haven't seen the 5-axis gimbal sets very often. So. Yeah, heat is heat. The argument is that the torch heats the tool holder unevenly, so it kind of builds up stress and torques it out. So yeah, there. Rambo there just said it. So yeah, the induction heaters heat the tool holder nice and evenly and consistently all the way around the circumference. So. Okay, guys, I'm gonna call it a night. Thank you everybody for watching, and I will be getting more videos out. You know, please bear with me. Have some patience. The videos that I'm making just take a lot more time to do, but believe me, it will be worth it. So hang in there. Okay, have a good night.